Welcome to the fourth lecture in Calculus 1. So let's begin. Alright, so for this lecture, we will tackle the so-called antiderivatives. So when we say antiderivatives, it is simply the reverse of differentiation. So for example, suppose we have a function, namely x squared, and if we take the derivative of f of x with respect to x, so we will get 2x. Now, we may say that the antiderivative of 2x is x squared, because if we take the derivative of x squared, we will get 2x. So that is the concept of antiderivatives. Alright, so for that, we may say that, or we may write the antiderivative of 2x with respect to x is equal to x squared. So this is how we write antiderivatives. So after we write the antiderivative of the function, we need to have this term, this plus c. So whenever you get the antiderivative of a function, you have to remember to put, or you have to put plus c at the end of the antiderivative. So another example, if we have, let's say, x cubed, we take the antiderivative of this with respect to x. So the answer would be x to the fourth all over 4, and then you put plus c. So to check if this is the antiderivative of x cubed, we make, so checking here, if we take the derivative of x to the fourth all over 4, so we will get 4x cubed over 4. So we can cancel out 4 to arrive at x cubed. Alright, so we are now at definite integrals. Now, in definite integrals, it is of the form like this, wherein we have numbers above and below in this integral sign. So we read this as the definite integral of f from A to B. Now, to evaluate this definite integral, we need to first find its antiderivative, or what we call the indefinite integral of f. So after we evaluate the indefinite integral of f, we first plug in the upper limit of the integration to f, or to the antiderivative, minus the lower limit. Alright, so for example, let's take the function bx squared. Now, we are going to take the definite integral of x squared with respect to x, let's say from 0 to 2. So we first do the antiderivative of x squared. So we will have x cubed over 3. Now, evaluating this from 0 to 2, so we first plug in 2 to x. So we will have 2 raised to 3 over 3. Then minus, we now plug in 0 to x. So we will have 0 raised to 3 all over 3. Now, evaluating this, we will get 8 over 3 minus 0. So the final answer would be 8 over 3. Now, let's have the application of the definite integral. So let us first draw a Cartesian plane. So let's have this blue area. So for example, we have this 1 and then 1. So this is 1 comma 1. So we have here a square that has an area 1. Now we know that the area of a square, so this is a square, is equal to the length of the side squared. So we have simply 1 and then square. Now, let us find, or let us do another method in getting the area of a square using definite integrals. So let us have a graph again of our Cartesian plane, and let's draw another square. We have here 1, 1, then we have 1 comma 1. So we all know that this function is described by this. And the area is bounded by this vertical line. So this is x equal to 0 and x equal to 1. So to get this area, so I will shade it with color yellow. So this yellow area can be computed by taking the definite integral from 0 to 1 of 1 with respect to x. Now, we all know that we can evaluate this by first getting the antiderivative of 1. So the antiderivative of 1 is x, and then we evaluate that from 0 to 1. So we first input 1 to x, then minus input 0 to x. So we get 1, which is the same as this.